You know I love networking, and if you've been following my recent stuff, you know I've been dealing a bit with cloud technologies and cloud certification. So I figured why not take a swing at trying to break down AWS from a network engineer's perspective, and so that's what we're going to do today. We're going to do a walkthrough of the fundamentals of AWS networking. Hey everybody, what's good? What's going on? JB here, back with another CyberInsight video, and today I'm pretty excited. It's something that I've been wanting to do because when I first started kind of learning about AWS and the different technologies that went into there, there's some really great training resources out there. There's some great information, but I haven't really seen it broken down, especially from the network engineering perspective, very much. And so I figured, since I'm learning about it, why not actually do a little bit of an in-depth breakdown of the fundamentals of the networking components, and hopefully this might be useful to some other folks who are coming from a network engineering background and are kind of trying to wrap their minds around really what's going on within the cloud, and specifically the AWS cloud. But before we move over into all that stuff, make sure you smash the like button, subscribe to the channel, all that other good stuff, you know. So let me just move over in my browser and then we will start getting into this. All right, so what I wanted to do was actually cover the key components of basic networking within AWS. I'm going to give you a few different resources that also will help answer quite a bit of questions, and then also show you how we can go about spinning up these individual components. Now, what this video is not going to be is going to show you how to spin up any EC2 instances, so creating servers and things like that. We could do that in some later videos. It's also not telling you how to set up an AWS account, how to get the right IAM or account management type of stuff set up, or any type of logging stuff, alerting, any of that type of stuff. This is strictly network engineering. And so we're going back to basics. We're doing Network Engineering 101, and we're going to cover all of those key components there. All right, so the first thing that we're going to talk about here is the basic structure that exists within the AWS cloud. So we're going to go into my little diagram here that I created. We're going to talk about a few different things. So we have the overall AWS cloud, and then within that cloud, they have a whole bunch of different regions. And these regions are all over the world. And what the regions are collections of a whole bunch of different data centers that are specific to different geographic areas. So if we actually go over here, I think we can probably find some maps here that will kind of break it down. So these are all of the different North American regions. So 1, 2, 3, 4, 5. You see they have these GovCloud ones, so that's going to be for FedRAMP stuff. So regular users actually can't put stuff into those, but all the rest of these most definitely. And you'll also see that they have availability zones, and we're going to go into what the availability zone is here in a second. But you see this is North America, South America, Europe, and Asia Pacific. So really, whenever you're building out anything within these environments, you're going to want to pick a region close to wherever your user base is, or wherever you're out of, or actually spread stuff across multiple regions if you do have users all over the place, so that the connection time is a lot lower for individuals connecting to whatever resources you're putting into the cloud. So we have all these different regions, and then, as I mentioned, within the regions, there is a whole bunch of different things called availability zones. An availability zone is either a individual data center or collection of data centers that are very, very close together. Again, if we go back here and just look at North America and we look at these different regions, we can see how many availability zones are in each of these different regions. So it could be 3 data centers within that particular availability zone, or it could be 1 data center within that availability zone. Now, one thing that is important to note is that no data center can actually span multiple availability zones. Again, we have the AWS cloud, within that multiple regions, within the regions, multiple availability zones. Now, as an engineer or a cloud customer, when we want to go and deploy something, what we are going to create for ourselves underneath our account is a virtual private cloud, or VPC. This is the primary container that all of the stuff that we're going to be deploying fits into. Now, the important thing to note with the VPCs is they can actually span across multiple availability zones within a region. So if you create one VPC, you're going to put that into a region and it can span across all of the different availability zones that are there within that region, but can't spread outside of that particular region. Now, we do have ways to connect a VPC in one region to another VPC in another region, but that is above our 101 networking that we're doing today. But I am going to do another video where we go more in depth into a little bit more of those advanced AWS networking topics. So some great places to start with as far as resources of understanding some of these things is AWS has great documentation. I'm going to put a link in the description below. Pretty much when you create a VPC, there's a few different things that are going to end up going into that. The first thing primarily is you're going to need some IP space. And you see here, it's a /16. You can use any type of RFC 19, 18 private IP space. You actually can also use public IP space too, if you have that you own as an organization. The only thing is there are some limitations with how they do the routing and advertising your specific public IPs out to the internet. So that might be something that might not meet your specific needs. There are obviously public IP addresses that will end up being assigned to resources later on, but that is not what happens in that initial step as far as setting up the VPC. So you can do IPv4, IPv6, and we're going to go ahead and create that. Some other things that the VPC FAQs is very good. So the main components that are in a VPC are all of these different things here. So we're actually today going to be talking about subnets, internet gateways, and NAT gateways. The rest of these we're going to leave for some later videos that go into some more advanced topics. Now here they're kind of talking about what you can do as far as IPs that you can use within the space. And pretty much what I just said or summarized is pretty much what's going to be in here. The default space that you're going to get is 172.31.0.0/16. And then within your VPC, you're going to end up creating multiple subnets. And we're going to hit that here shortly. One thing that is worth pointing out, if you are going to have multiple VPCs across multiple regions, or even within the same region, and you want them to communicate with each other, you're going to have to make sure that you use separate RFC 1918 space so that you don't end up having any devices that have overlap with different IPs. That is if you want them to be able to communicate with each other. So one thing that you should be aware of is that there are some limitations in the amount of IP addresses that you can create and VPCs that you can create. And some of these things are just default. A lot of times you can just send an email to customer support. I had to spin up some additional VPCs. There was a limitation, I think, of 5. I sent them an email, and within 10 or 15 minutes, they took care of it, and it was good to go. So just keep that in mind, that you might run into some initial limitations that you're going to have to send some emails for. Again, at this point, everything that we're doing is free. It doesn't cost any money yet. So creating a VPC, you're not going to be charged for anything. One thing to note from a network engineering perspective is the range of CIDR notation you can use. You can go all the way down to a /28 and up to a /16. Now let's move over and look at the next thing here. Once we have a VPC identified and created, we then go and create some subnets out of this particular range that we have. So they use some nomenclature that, as coming from a network engineering background, is a little bit confusing, and I didn't really care for it too much. And that is private subnets and public subnets. You know, for those of us that have been doing networking forever, when we hear private, we think 1918 space. Public, we think publicly routable space. And that is not really exactly what the nomenclature here means. A private subnet is a subnet that will not have any direct inbound connections from the internet going to it, where a public subnet is something that you would put devices in there that you plan to have direct connections from the internet come into it. But in this case, we're still talking about two different subnets that are RFC 1918 space. And there's going to be some other networking components that we're going to add in later on to make sure that we can get access into that. And we'll be using, if you want to take a guess, NAT. So just something to keep in mind that we're going to hit up here in the next few steps. But looking at the subnets that we can use here, if we go back to the FAQs, we actually can create up to 200 subnets per VPC out of that larger subnet that we assign to the VPC. And again, the minimum size is going to be /28. Again, from a network engineering perspective, one thing that is good to understand is the amount of IP addresses that Amazon eats up right off the beginning when you go to put one of these subnets into use. They take 5 IP addresses. So first 4 IP addresses in the subnet, and then the last one. So just be aware of that so that when you're planning any type of IP address assignment, they're using that for failover routing and things like that. So they are going to a good use. They aren't just being kind of greedy with the IPs. So at this point, we have identified what we want our private subnet to be and what we want our public subnet to be. We have those in place. And now we're going to look at the other networking components that we need once we've identified the subnets. And that's going to be some security and some actual routing for them. So within the subnets, we're going to need a routing table. Now, something that is worth pointing out is we could actually have the same routing table across multiple subnets. But here, when we're talking about a subnet that's going to be a public subnet and a subnet that's going to be a private subnet, the default routes that we're going to be using in each of those subnets are going to be different and pointing to different networking devices within our VPC. Now, we don't know what those are yet, although I did mention them briefly when we were going through the overview stuff. That's going to be the Internet Gateway and the NAT Gateway. We're going to talk about the differences between those and why we point one towards the other. But since we do know that we're going to need to have the private subnet pointed towards the NAT Gateway and the public subnet pointed towards the Internet Gateway for its default routes, it's best practice to separate those out and have different routing tables. The other thing that we have here from a subnet level that takes care of some security is a Network ACL or NACL. Now, this is just like if we were to put a IP access list onto a subnet within a networking environment, or if we were to attach a VACL or something like that. It's going to apply to the entire subnet. It has both an inbound and outbound directions that we are going to need to configure because this is not a stateful security policy like a firewall. So that is something that you're going to want to keep in mind, that if you are sending traffic out through this NACL, the response traffic is going to have another rule for the return traffic coming back in. Now, in between here, we see that there's a router. We actually don't need to do anything with that. That kind of just happens by the fact of us creating a route table and associating the subnet to that route table. So there is some networking that happens kind of on the back end here that is quote unquote magic, that we don't really necessarily have any control over those individual devices. That is what AWS is handling for us. So the next step here, as I mentioned, is this public subnet, in order to get out to the internet, is going to need what's called an Internet Gateway. And we can see that this Internet Gateway sits over here. It's also worth pointing out that this Internet Gateway resides within the VPC, but because the VPC can span across multiple availability zones, then the Internet Gateway is able to support multiple availability zones as long as that is within that particular VPC. So the route table for this particular subnet, or I should say the route table that has this subnet associated with it, would then have a default route pointed towards the Internet Gateway. Now, at this point, we actually don't have any actual devices deployed within the environment, so we're putting these things in place. Again, we're doing the networking aspect of this, but we haven't necessarily moved into like the systems engineering aspect of this. In that point, we would end up spinning up some EC2 instances, so some servers or other things like that. It would have a private IP address assigned on that, but then we would need to get elastic IPs which are their term for public IP addresses. So we would take an elastic IP address, we would get it assigned to us. Those do cost money. So that is something to be aware of. The time that you are either holding it and it's not in use, you get charged for that. If it is in use and assigned to a EC2 instance, you might not be getting charged for that depending upon what tier of EC2 instances you have. If you're in the free tier and you still have hours available on that. So that elastic IP address would get associated with whatever the EC2 instance is, whatever the server is. But the IP itself actually doesn't get applied to the server. There is some NAT that actually happens on the device that is doing the internet gateway actions. And that actually will have a NAT table that will take the IP address of the EC2 instance and NAT it to the public IP address of the elastic IP. Now remember, in this case, because this is in the public subnet going to the internet gateway, that also means that there can be direct access from the internet back to whatever that device is. In this case, the network ACL or NACL can have some rules in place to allow that traffic to happen. There's also another type of security configuration that we can do called a security group that in essence acts as IP tables that can be assigned across multiple devices within your VPC. We're not necessarily going into the security group stuff here today because, again, we're just focusing strictly on the networking components of this. But in one of the future videos, I'll actually show you what one of those security groups is and what it looks like when we attach it to an EC2 instance. So we got the public subnet, good to go, routing table, default route to the internet gateway, a NACL that is controlling the traffic. And then the last thing that we wanted to talk about was we still have this private subnet over here that's not doing anything. They are able to talk back and forth to each other because there's a local route in both of these routing tables. But as far as this guy actually being able to go out to the internet, let's say you needed to go out to pull down patches or something like that, or even actually to be able to be managed by the session manager within AWS, it's going to need connectivity to the APIs that AWS has. Now, you can either do that by allowing it to have access to the internet, or there's some other things you can do with VPC endpoints. Again, that falls a little bit outside of the scope of kind of networking 101, but there are a few different options that you have there. But in this option, we're going to talk about getting it access to the internet. So what ends up happening there is we end up deploying a NAT gateway. So this NAT gateway actually is going to go into the public subnet, but the routing table in the private subnet is going to have a default route that points towards that NAT gateway. And you can see this connection from the NAT gateway here that symbolizes the actual network connectivity that's going on between the private subnet, the public subnet, the routing that's happening within AWS and going out to the internet gateway. This NAT gateway, again, is going to get an elastic IP assigned to it. So all of the traffic that is coming from the private subnet and pointing to the NAT gateway is going to get NATed to that public IP address. And out to the internet it will go. So let's go take a look at how easy this is to actually spin this stuff up. So this is my CyberInsight lab. We actually could go through and individually spin up all of these things. We also could use some different types of scripting to be able to do this. We could use CloudFormation, we could use Terraform. There's a whole bunch of different ways to do that. And we actually are going to do some of that in some later videos. I think that would kind of be good to walk through that. But we're just going to go the straight and easy way just so you can see how really, really simple it is to get one of these VPCs spun up with all these different instances. So what we're going to do is actually use a Launch VPC Wizard, which is super straightforward, and it will show you how easy it is to do this. And all it really takes is us having a better understanding of the networking and the reasons behind the different components that we need. And it's going to do all of the connections and stuff like that for us. So we're just going to click Launch VPC Wizard. So we could just create the VPC by itself. And if we do that, then all that would do is spin up the VPC. It doesn't give us any subnets. It doesn't give us any NACLs, no routing table entries, no internet gateway, no NAT gateway, none of that stuff. We're not going to do that. We're going to go VPC subnets and etc. The cool thing as we're looking at this is it actually walks you through how all of this stuff goes together. So in this case, it would be creating a single VPC in 2 different availability zones. Now within those different availability zones, it would make both a public and a private subnet, right? And then when we highlight this, we can see the routing tables that each of those would be going to. So there would be 1 public route table and then 2 private route tables. And then other things that we need over here, they show an internet gateway and a VPC for connection to S3. S3 is like a data bucket place where you can store different types of data. But we aren't going to do all of this. We're going to make this a little bit simple. One thing that is really important and helpful is within AWS, they have this thing called tags. And pretty much whenever you create any type of resource here, you can use a tag to give it some different type of nomenclature. This will make things so much easier for you as you build out different things. Normally, there's going to be a default subnet or default route table, different things like that that actually get created. Doesn't mean that you necessarily have to use that. Normally what I would do is go and tag those as default and then go and create a separate one just that I know that I can mess with and it won't actually mess anything up by, you know, deleting the default stuff. But use tags with names that make sense. So in this case, we'll call it YouTube test. And you see by using this auto tag or this tag auto generation, then you see it ended up applying the name across everything. So when we go and we look at all this stuff, once it's completed, it'll be very easy to see which components were actually created, and we can see how they're associated with each other. So in this case, we could choose any public or any private IP space. Shouldn't say that because that's really confusing because of AWS's nomenclature. We can choose any RFC 1918 space. In this case, we'll just go with a 10 network /16. We could go with IPv6. We don't really need to do that. Something you want to be very careful about. We want to go default. We don't want to go dedicated. If you go dedicated for these different types of services, then that's going to end up being a lot more expensive. You don't want to do that. That will be bad. So availability zone. So here it's going to be creating 2. For operational purposes, that would definitely be what you would want to do. You would want to have multiple availability zones, multiple subnets, multiple resources. You use load balancers and things like that to make sure that you have some redundancy in place. We don't necessarily need to do that today, though. We're just going to go 1. And it allows us to choose which availability zone we want to go into. So we're going to use USA East 1A. That's important. Again, whenever you're creating different things, you do want to be aware of what region you are in. So up here, we are in US East, specifically US East 1. There's all these other regions that we could go to and do stuff in. If you create something in a different region, you need to remember where you put it. So if you log in somewhere and you're like, hey, I don't see the stuff that I know that I spent time building out, make sure that you're in the right region where you put it. Also, something else kind of weird, I think all the billing stuff, actually, you need to be in US East 1 for that. So we're just going to use US East 1A. Number of public subnets. So I think 1 public subnet is perfectly fine. Number of private subnets, that should be fine. We're just going to go with 1. We could go 2, but we're just going to go with 2. We can specify how we wanted this to be broken up. So it's going to default to /20s, but maybe we want to be a little bit more judicious with what we're doing. Maybe we want to go 10.1 and 10.2 and just use a little bit less space. So we can make those /24s. Cool. Now, when looking at this, we already have an internet gateway, right? You remember we need that for the public traffic to be able to go in and out. Do we want a NAT gateway? Well, since we have a private subnet, and in this case, we needed to have access to be able to pull down patches, then we are going to go, we are going to add one. So we could go one in the AZ or one per AZ. Again, it just depends on what you want to do. In this case, since we only have one AZ, then that's perfectly fine. So we're going to do that. Now the last thing, do we need any the S3 gateway? Well, since we aren't actually sending anything to any S3 buckets, we won't spin that up. And we will want to enable DNS resolution. So all this stuff, let's see how long it will take for us to do this. So let's go 10.0.24, 10.0.20/24. Okay. Let's see if that makes it happy. All right, so created the VPC, enabled DNS resolution, making sure the VPC is created successfully, creating both of the subnets, creating the internet gateway, attaching the internet gateway to the VPC, created a route table, created a route, associated the route table. We got an elastic IP address that's going to end up being attached to that NAT gateway. This one will take a minute or so for that to actually go through and get validated. We're just waiting for the NAT gateway to activate. All right, so then NAT gateway's activated, created the route table, created the route. Now let's go see what this all looks like. So let's go back and kind of step through what we have going on here. So we have the VPC, and then we have a main route table and a main network ACL attached to those. Let's go take a look at the subnets. Now you will see some of my other stuff that I've already created and named, but we will see the YouTube ones. Both of those there. We can see the route table and network ACL is attached to both of those. Now if we go and take a look at the route tables, again, we can filter on that particular tag that we created. Now we see here this looks to be one that's associated with the VPC, doesn't have a tag with it though. Well, let's see if it has any subnets associated with it, which it shouldn't. No. So this was the default one that was created, but didn't end up getting used. And then we actually created two separate ones ourselves when we used a VPC Wizard. So if we actually go, we can see that it has an explicit subnet association. Again, great using those tags, and then you're able to see. So we have the private subnet and the public one. So if we go actually look at this route table, we can see a few important things. First off, we have a local route for the whole /16. So this is how traffic in the public subnet and the private subnet are actually able to talk to each other. Both of them in the routing tables actually have this that allows the local traffic to be able to talk to each other. Then here we have a default route for the private subnet going to this NAT device. And if we go back, for the public one, it's going to be pretty much the same thing. The route table is going to be associated with the public subnet. And then again, that /16 local route, the default route pointed towards the internet gateway. Now the last couple things that we would want to go take a look at here, we can look at the internet gateways. We can click into this. It's really, all you're going to see here is the fact that it's attached to the VPC, the NAT gateway. Only have one. Now, worth mentioning again, just a reminder as far as things that do cost money, the NAT gateway and the elastic IP addresses are going to cost money. So keep that in mind when you spin this stuff up. It doesn't cost a lot of money, but you will continue to be charged a few cents every hour. So just be aware of that. So we have this NAT gateway. We can see the elastic IP address that was associated with it. So anything in the private subnet going out to the internet is going to be NATed to this particular IP address. We can see that the private IP address is actually part of the public subnet. And then I think the last thing that we would look at here is the NACLs. So there isn't a name associated with this, but we can see that it is associated with the YouTube test VPC. And so if we actually see the subnet association, we see it's associated both with the public and the private subnet. Inbound, outbound rules default to just allowing all traffic. So we would either want to tighten these up, or we would want to make sure that we have security groups in place on all of the different EC2 instances and devices that we're spinning up within the environment, and attaching those security groups to those. So I think that should about wrap that all up. So just to recap, we talked about the overall AWS cloud, all the different regions that are across the world. All the different regions have a different amount of availability zones, which is a data center, collection of data center within those. And then you as a customer go and create a VPC. That VPC can span multiple availability zones, but has to remain within an individual region. Within the VPC, you have different types of subnets that you're going to spin up, both public and private. Private could have access to the internet, but internet doesn't have access to it. Public has access to the internet, and the internet can access it. In both cases, probably RFC 1918 space. In order to get publicly routable space associated with those, you're going to need to use an elastic IP address. Within each of those subnets, we have a routing table. Remember, the default route in there is probably going to need to point to something to get out to the internet. For the private subnet, we need to point to a NAT gateway. The NAT gateway needs to reside within the public subnet. The public subnet would need to point towards an internet gateway. And then I think the last thing that we covered was the non-stateful NACLs that you can use to help provide some type of IP filtering within the environment. So I hope that was useful. Tried to break it down from a network engineering perspective. If you did find the video interesting, please smash the like button, subscribe to the channel, share it with other people. Drop me a comment down below on some other AWS networking things that you'd be interested in me covering. I want to talk about transit gateways, some VPNs, a little AWS cloud back to on-prem site, IPsec connections. There's a whole bunch of other networking topics that we can kind of delve into, which aren't necessarily always discussed from a network engineering perspective. So I think it would be worth doing that, and hopefully that will help some other network engineers that are starting to migrate some stuff to the cloud. So as always, appreciate everybody dropping in. Hope you have a great week, and we'll chat soon.